Okay, our next functional group is esters. Esters contain a carbonyl group attached to an oxygen attached to another carbon. So this is called an ester linkage. Esters are compounds with pleasant odors and flavors. And you often find them in nature. The scent, they cause the banana smell that you smell, or the smell in fruits. And they're used, they can also be used, if they're synthetic, if they're man-made, they are actually artificial flavoring. So once we've identified the chemical compound that makes the flavor, we can synthesize them in the lab, and then they call them artificial flavors. To make an ester, react an alcohol with a carboxylic acid. And because you use these two types of compounds, the names of the alcohol and the acid are used to name the esters. So when you have an ester, you have to identify the portion containing the carbonyl group. The C double bond O. This portion came from the acid, and this becomes the root for our ester name. So this is from the acid, and it becomes the root. So what we do is we drop the oic acid and we add O8. So if we use propanoic acid, that term would become propanoate, and that would be our root for our name. Okay. The other portion of the name is on the other side of the single bonded O. So it's the side opposite of the O from the carbonyl group. And this portion came from the alcohol. So identify the length of the carbon chain. And what we do is we take off the OL from the alcohol, and we put on a YL. So we make it an alkyl group. So if we had two carbons, it would have been ethanol So this becomes ethyl. And this is the prefix for the name. So the acid portion comes second, the alcohol comes first. The alcohol, you change the ending to YL. The acid, you take off the oic acid and add O8. So if we have ethanol plus propanoic acid, we would actually make ethyl propionate, which is our ester, and we also produce a molecule of water. So that would look like this. The alcohol was 2 carbons long, and the acid was 3 carbons long. Here's the first carbon, second carbon, third carbon. So this is what ethyl propanoate looks like. If there's a side group on the carbonyl side, it becomes part of a prefix. And the number is the position from the carbonyl group. Now, if this happens, we have the prefix from the alcohol first. Then we have the prefix from the side group. And this is attached to the acid portion of the name. So if we had I'll leave the hydrogens off just to make this simpler. Less cluttered. Here we've got our functional group right here. Here's our ester. So that means this portion came from the alcohol, and then this portion came from the acid. Okay, so the alcohol portion comes first. There's 2 carbons, so this becomes ethyl. There's a side group on the acid portion, and it's a methyl group, so that comes next, including which carbon it's on, because it could be on 2 different carbons. It could be on this carbon, or it could be on this carbon. So we have to identify which one it is in this case. So this is carbon 3. So this is 3-methyl, and our carbon length for the acid is 4, so butanoic acid, so butanoate for the ester. So ethyl 3-methylbutanoate. Let's try drawing these. So the first part tells us the alcohol portion, and the second part tells us the length of the acid that was used. So let's start with the portion that was the acid. So it contains a C double bond O and propanoate, so that had 3 carbons. So carbon 1, carbon 2, carbon 3. So there's the one portion of our ester. The second portion came from the alcohol, and it was butyl, so butanol. So 4 carbons in our carbon chain with a single bonded O. So there is butyl propanoate. Okay, next one, ethyl 2-cyclopentyl hexanoate. So this is our alcohol portion, and this is the portion that came from the acid. So it was hexanoic acid with a cyclic side group. So let's draw the acid portion first. 4, 5, 6. There's our double bonded O. And it had a cyclopentyl group on carbon number 2. The C double bond O is carbon number 1. So here's carbon number 2. And it had a cyclic pentyl group. And we go back in, stick in our H's, and here's our hexanoate portion with a cyclopentyl group. So that leaves the single bonded O with the ethyl group. And there we go. There's ethyl 2-cyclopentyl hexanoate. So just remember, the very first prefix comes from the alcohol. Any other prefix is attached to the carbon chain that came from the acid. Okay, physical properties. So they're slightly polar because they have a C double bond O and they have this CO C bonds. So it is polar. So they will have London dispersion forces and dipole-dipole as their intermolecular forces. No hydrogen bonding, but they can accept if something wants to hydrogen bond with them. So they have a lower boiling point than the same length alcohols and carboxylic acid, but higher than alkanes. In terms of solubility, can only accept hydrogen bonds from water. So the small ones, carbons 2 to carbons 4 in length, are soluble. But anything greater than 5 are insoluble. So, esters are either liquids or waxy solids, and they have an odor, so they're volatile.